Welcome to the video tutorial for users of SwIMA's Express Windows installer. Here, I will explain the basic use of SwIMA, including the most relevant parameterization, how to run the quality control steps, and how to access the results. This is RStudio, the software that launches if you click on one of the shortcuts created during the installation. The window is divided into 4 areas. For now, focus on the lower right corner. Here you can see SwIMA's files, and this is where you can also access the results of your analysis. The input files are SPP and groups, batches, contrasts. The rest are manuals, scripts and apps. On the upper left corner, you will see SwIMA's code, and, importantly, a button that says Compile PDF. The bundled example study can be analyzed right now by simply clicking this button, so let us do it. If this is the first time you run the script, be patient while libraries get installed. Otherwise, what takes up much of the time in this example is the loading of the libraries. In the meanwhile, what we see is that a folder called Example Project has been created, containing the results being generated. The name of this folder is set on the PROI folder, parameter, always between quotation marks. Once SwIMA finishes, the report is opened. This report can be found in the main folder, along the main script and with the same name ended in .pdf. You might want to create a new copy of the main script and change the PROI folder parameter for each analysis you run. Let us take a look now at the example studies information file, called Groups, Batches, Contrasts. Here, you can see that Group 1 contains 5 samples, whereas Group 2 has 6 samples. If we scroll down, we see that one of the comparisons we want to make normalizes Group 2 against Group 1, a process that requires the same amount of samples in both groups. Because of this, a sample from Group 2 has been excluded using the excluded samples parameter in the script. In order to decide for ourselves whether to exclude another sample instead, let us set the parameter to null, so as to not to exclude any, and scroll down to set the DoOnly quality parameter to true, with a capital T. This way, we will just perform the quality control steps, including the PCA and hierarchical clustering, and we will decide whether excluding sample 8 was the correct choice. Let me remove the results folder, and we are ready to run the quality control steps only. It is not my intention to go into detail on the interpretation of the results, but, based on the graphical output, it seems as though none of the samples have quality issues. Hence, the removal of sample 8 was a random choice as good as any. If we wanted to remove more than one sample, the easiest way to specify it is writing down the names of the samples between quotation marks separated by commas, preceded as a whole, by a letter C and within parentheses. We have already seen the 3 basic parameters, but let us take a look at the rest. We can exclude probes in sexual chromosomes, methylation probes known to contain SNPs, and those not annotated to microRNAs, in the case of human expression assays. By default, sex chromosomes are included, and probes are not filtered based on SNP presence or annotation outside microRNAs. Moving on, the script offers the option to correct possible batch effects, using a method called combat. You should only use it if you are sure of a big batch effect, and should still check that results are improved. If you are rerunning an analysis, you might want to avoid spending time creating the output tables again. In such case, set writing result and Miami tables to false. Also, much of the time taken by SwIMA's analysis is consumed by the gene set enrichment analysis, particularly GEO, KEGG and REACTOM. Set any subset of these to false if you want to skip them, either because you are not interested in them, or for the sake of time. Before continuing, let me remind you that all these parameters come with a default value that will most likely serve your purposes most of the times, so take your time getting acquainted with them as you perform analysis. Next, you might choose the name used for the group containing the reference samples used to check hybridization correctness. These samples will not be used after normalization. You might also choose the location and name of your information and data input files. For example, this indicates that the info file is within a subfolder called input. If in methylation you are using the 27 KB chip instead of the newer 450K one, change this parameter. SwIMA works with two levels of change and significant strictness. You may change the two thresholds for both the p-values and fold changes, /m values. Then, you might choose to use the more strict or more relaxed combination when plotting, and for the gene set enrichment analysis. The high-density Infineum human methylation 450 microarray contains a huge amount of probes for certain genes, making them much more likely to present significant probes just by chance. Put a threshold here to delimit the p-value of the statistical test. That keeps for gene set enrichment only those genes with more significant probes than expected. Gene sets from certain collections are plotted if significant. Delimit here how significant they must be in order to be plotted. The rest of the code is somewhat annotated, and sporadic eye users should not have trouble changing many other variables in order to adapt SwIMA to their needs.